In this video, we'll be looking at the last analytical method to evaluate a limit. This particular limit is x approaches 7 of this fraction with x minus 7 in the denominator if I attempt to plug in 0. Now in a previous video, when I plugged in 7, I ended up with something that looked like this. I would do 7 plus 2 minus 3, and I'd go ahead and do 7 minus 7. I would end up with 0 in the denominator, and on top I would end up with 3 minus 3, which is once again 0 over 0. This particular 0 divided by 0 is what we call an indeterminate form. We will review that more in the future. However, for right now, we have to know that anything divided by 0 is mathematically inappropriate. Now, the reason why I write an arrow here and not an equal sign is to emphasize the fact that I'm attempting to plug in the number. Now, I kind of have to know ahead of time when I go to plug in the number whether or not it's going to work. So by plugging this in, I'm showing the work that I've checked whether or not it's going to work, and I know that it's not. So that means what I'm going to have to do is I'm going to have to evaluate this limit in another method before I can plug in that 7. Well, knowing that there's an x plus 2 inside of a square root minus 3, and that x minus 7 is causing me a problem, tells me that I know I'm going to have to use a method called conjugation, or simply multiplying the top and the bottom by the exact same radical, the exact same number, but this time it's going to have a plus sign between the two values instead of a minus sign. Now, if the sign here was a positive, then we would put a minus sign here. We also can't change the value of the interior of that limit, which means that I have to multiply not only the top but the bottom by that conjugate value. So in doing so, I can now identify that by multiplying the stuff on top, something nice should happen. And in the denominator, I know that this right here, this x minus 7, is a problem child. Knowing that this is the problem child, I don't want to actually manipulate this in any way until I'm ready to plug in x equals 7, and that has to be gone for that to happen. So that means anytime that I have a problem child here in the denominator and I'm multiplying by a conjugate, that conjugate shouldn't be distributed to that problem. So what I'm going to do now is I'm going to go ahead and simply multiply out the top. Very carefully, I'm going to have the radical x plus 2 times the radical x plus 2, giving me simply x plus 2. I'm going to have the positive radical times positive 3, so plus 3 of that radical. I'm going to have negative 3 times that same radical, minus 3 radical x plus 2. And then I'm going to have negative 3 times the positive 3, giving me negative 9. This is all still divided by, and again, I'm not multiplying out x minus 7 to anything. So it's going to be x minus 7, and then the radical of x plus 2 plus 3, all multiplied in the denominator. So, with that done, you'll notice the interior pieces here and here. Those two things will cancel out. They're exactly the same, but one's a positive, one's a negative. You'll also notice that I have x plus 2 minus 9, which means that inside the limit, in the numerator, I now have x minus 7. So sure enough, just like we needed, the x minus 7 that's in the denominator will cancel out with the x minus 7 that is now on top. This is going to provide me with the limit as x goes to 7, and again, I strongly recommend that you write this fraction before you plug numbers in. It'll be very easy for you to accidentally make a mistake. By plugging in 7, you'll end up with 1 over the square root of 7 plus 2 is 9 plus 3, which is then 1 plus 3 plus 3, sorry, 1 over 3 plus 3, which is then 1 over 6. And my final result for this limit is 1/6. And again, notice, immediately after plugging 7 in, I no longer have the limit function written in the beginning of the problem.